Okay, 5:30. We are almost at the end of July, and it finally decided to stop raining in Houston. We had a bizarrely wet uh, uh, May, June, July, just odd here for Houston. Normally, it stops raining right around early May, and your lawn's dead by June, and Houston, Texas. But boy, weird weather this year. So that is that's starting to settle down. What is, of course, heating up is DevOps Days Houston. We are still set to go live and in person September 21st and 22nd. That's the plan right now. Anybody that tells you that they know what's going to happen a month from now in the year 2021 is absolutely fooling themselves. No one knows what's going on, but we're still cautiously optimistic. Fingers crossed that we'll be able to go live and in person with DevOps Days Houston. We're putting together the talk list right now, and got a fantastic set of speakers lined up. We're trying to get as much content in there as possible, as many workshops, open spaces, lightning talks, and long form talks as possible. And so, again, cautiously optimistic, everything's going to happen, and we're going to be able to get this thing rolling and be able to see everybody, and of course do it safely with everybody's best interest at heart. But looking forward to it. Looking forward to getting back face to face with people. We're of course aware and keeping an eye on the evolving situation with the new Delta variant, but I guess we'll see what happens there. Many thoughts, many opinions on that, and I'll keep those all to myself because no one wants to hear it anyway. Imagine that. Okay, so why do we do the Houston DevOps meetup? What is the Houston DevOps meetup? Well, it's about community. It's about getting people together. The cloud moves fast, is what we like to say in the Houston DevOps meetup, and you just can't know everything. But that's not our jobs, right? Our job isn't to know everything, but it's at least to have a path to, or an answer for, or a response to the things that come up. If you don't necessarily know a whole lot about AppSec monitorability or observability, then you can jump on the Houston DevOps meetup and meet a bunch of like-minded professionals that are great at their jobs and might know somebody like Kieran out there that could help them with that. So there's, with as many things that are happening, with the amount of expertise that's required, it just makes sense to have a good network. So we are about that network, getting people together, talking about not only what's working but what hasn't worked, and sharing our experiences. It's my goal with this Houston DevOps community to develop to develop that mentoring kind of ability, and to get the Houston developer community aligned so that we can all find out who's doing what and cross-pollinate with the various things that we're doing. So that's the idea. Get together every month at least and talk about what's going on. Got a great presentation for this month. Be handing that over here in a minute. Got a couple more. We actually have 2 scheduled for August, trying to squeeze a couple in there before the end of the summer. And of course, before DevOps Days Houston goes live. So all that being said, that's what we're doing. That's what we're here for. The meetup is typically monthly. It's always free. We have about 1,000 members right now, and that grows every month. And looking forward to seeing what we've got on store for the presentation today. So thank you everybody for jumping on. I will kick it over to Kieran.
Awesome. You guys hear me okay?
Yeah, I can hear you. And I will set you as presenter.
Thanks.
Okay, so you should have the ability to share your screen, Kieran.
Awesome. You should be able to see my slides now.
Yes, we see the slides.
Perfect. Yeah, so thank you everyone for the opportunity to present here. Really appreciate that. And today the goal is to, talk about as a company that is creating an observability platform for application security. I wanted to actually talk to this group, which is obviously extremely well versed in the area of DevOps. about this up and coming concept of using observability to make your security, to create the most secure DevOps pipelines. The goal here is not to do a sales pitch of our product. The goal is to purely provide a thought leadership point of view on why observability is the next big thing for application security. Feel free to stop me anytime. Let's make it interactive. Let's make it a conversation. If you guys want to dive into a demonstration of the product or things like that, then we're more than happy to take those calls. We could set it up and have one of our engineers reach out to you and for a deeper dive and whatnot. So just a bit of an overview of myself. I'm what people call an addicted entrepreneur. I go from small company to big company, small company to big company, and then back to the small company again. Every time I find myself a comfortable big company job, for some reason, I get up and resign and go back to a startup. It's that's that's what happened in the last 20 years of my career. But I really enjoy what I do, and I like to build novel, cool things that hopefully change the way things are done by the industry. Over the last 20 years, I've done a couple of companies. One was sold to Citrix. One, my previous company, ContainerX, where we built a turnkey Kubernetes in a virtual appliance, sort of like Red Hat OpenShift or Rancher. That was acquired by Cisco, and it's now called Cisco Container Platform. While at Cisco, I was the head of product for Cisco's cloud business unit, so I was responsible for their OpenStack, container networking, Kubernetes, and a few other products and teams. And this bug bit me again. I felt like there was this huge gap in the industry as we move from DevOps into DevSecOps. We don't have the right tools to graduate from where we are today with having figured out how to do CI and CD, but there's this gap that needs to be solved before we as an industry can go to the next level and say, you know what, I've got security completely taken care of. I don't think we're there today, but we as an industry are moving in that direction, and it's an absolutely important problem to solve. So I put together this small team, really bright people at RinkQ, at DeepFactor. My co-founder, Mike Larkin, he's the father of the OpenBSD hypervisor, and we have a bunch of other folks from Qualys and FireEye and Department of Defense and HPE and Cisco, etc. Really bright early team. We're 20 people, and we're going to get to 40 people in the next 9 months or so. So in a rapid phase of growth in the company's life cycle. So that's a quick overview of the company. And the shortest way to think of DeepFactor is we're creating a Datadog for application security. That is the best way to think of us. It's a shifted left Datadog for application security. Let me tell you what I mean by that in a bit. So if you think about the challenges, so why is this such an important problem to solve, right? If you think about the challenges in application security today, and let's talk about the challenges and what is the right way to address these challenges. Challenge number one is that we're seeing more breaches than ever before, and we're seeing bigger breaches. Anytime, every company is now a software company, so there's a lot more software out there. There's a lot more SaaS application and other things that are collecting users' data and important data, PII and whatnot. So every time there's a breach, then a lot of users' information is being compromised and now in the hands of the attackers, and that's not a good thing. The second, so for this problem, how do we continue to respond to this rapidly changing threat landscape is we've got to make sure that we secure applications at the source. And we can put together good perimeters, around your, firewalls and other vulnerability scanning, on your hosts where the application is installed, and, web application firewalls and port filtering and so on and so forth. And that's great. You're putting together a great perimeter, but we all know that perimeters can easily be breached. And therefore, it's extremely important to make sure that you're creating a secure application to begin with. So, and especially modern applications have an increasingly large portion of your application today is third-party code. So 75 to 80% of the stat of most web applications are third-party components. So when you have a lot of these, your applications and third-party components, it's important to make sure that you secure them and create a secure application to begin with. And the problem is compounded today because you're moving at a super fast pace. Faster releases, more microservices. So basically what's happening is your apps are more complex, They're moving at a faster pace than ever before, thanks to CI/CD, and the complexity of the breaches and the size of the breaches is increasing. So basically, the situation is that it's very easy to make a mistake and a security flaw to get into prod, but if you do so, the punishments are higher because of compliance standards and other things. So what do? How do you continue to accelerate your digital transformation speed, which is what your business would want, while maintaining security, which is what your CISO would want? It is by truly enabling the dev teams and QA teams with the right security tools. You cannot have this gated model that we've had so far in the past, where the AppSec team comes in and finds issues towards the end of the release and hope that they find all the issues in your product. It's just not humanly possible. You have to make sure that finding security issues has to be baked in during the course of the development. And guess what? Guess why it's not humanly possible? Because there's a severe shortage of cybersecurity talent pool. There's apparently 3.5 million unfulfilled cybersecurity jobs by 2021, which is already 1 million greater than what it was in 2014. So how do you manage the shortage of AppSec talent? It's by automating security into your CI pipeline. So if you were to tie together all of these solution bullets, basically what we need to do is we need to secure applications at the source by enabling dev and QA teams with the right tools and automating security into your CI pipelines. That, in a sense, is what is needed for us as an industry to go from DevOps to DevSecOps with confidence. When we talk to customers, we've talked to more than 100 enterprises over the last year and a half or so. We group these enterprises into a bunch of different buckets, 4 stages of maturity. Stage 1, believe it or not, we still run into customers that are in stage 1, which is they have zero security in place. Devs write code, QA test functionality, the release ships to prod. Stage 2 and 3 are probably the more common stages that we see. Stage 2 is you have gated security checks, which is devs write code, QA test functionality, release ships, but towards the end of the release cycle, you dedicate a certain amount of time. 2 weeks, for example. 2 weeks is a common amount of time, 2 or 3 weeks, depending on the complexity of your application, for AppSec team to come in and find these security issues. But as we all know, it's impossible for the AppSec team to find all the security issues and also tell you that they can find everything in 2 weeks because of the complex nature of the varying nature of your applications. So what typically ends up happening is AppSec team finds some issues. Developers are suddenly context switched. There's a security issue found, all hands on deck, trying to fix security issues, and your release gets delayed. AppSec team, therefore, is viewed as the villain by the dev teams because they're the guys that come in at the last minute and delay your releases. But when in fact, AppSec team was just trying to do their job. So the solution was to start integrating some kind of security visibility into your CI pipelines. Hence, we've had some companies evolve into stage 3, where they have basic DevSecOps in place, where you have code scanning. The acronym for that is SAST, Static Application Security Testing. You have software composition analysis, short for dependency scans. So if you put together code scans and dependency scans, you're basically scanning your code, you're scanning your build images or container images. And that's great. That's a good way to find some of the security issues. But if you notice, we have not yet run your application. We have not looked at a running application and found any security issues. When in fact, the closest to what your application is going to do in production is when your application is actually running. So we're missing that. So that brings us to the holy grail of where DevSecOps should be, which is DevSecOps with continuous observability, where while code is being written, it gets scanned. Once your build images are produced, they get scanned for known vulnerabilities or CVEs in your build artifacts or container images. And then when your application is running, something, a tool, a platform, observes every thread, every process, every container of your application while it's running across all the layers of behavior, system call interface, web interface, network URIs, file accesses, et cetera, takes all of this rich data and then detects a bunch of anomalies and says, you know what, when your application was running, it was doing these things wrong. We found these risks in your system call interface. We found these behaviors that were not acceptable by your AppSec policies. We found these vulnerable libraries that were being loaded by your application, so on and so forth. That is the holy grail of DevSecOps. DevSecOps with continuous observability. So if you did have AppSec observability in place, then you could get to stage 4, which is where we as an industry need to get to. If you look at the existing tooling doesn't lend itself well for us to get to stage 4, which is why observability is absolutely paramount. If you think about existing tooling, we have tools that find risks in your code, SAST tools that find risks in your build images. And then when it comes to runtime, starting all the way from running in your test through to pre-prod all the way to prod, we have some tools, DAST and IAST, dynamic application security testing, interactive application security testing. IAST was designed 10 years ago. DAST was designed 15 years ago. So there's a bunch of, it was all before the concept of DevOps even existed. So there's a bunch of things that need to change in that area. So if you look at the tools on the left, the tools that we at DFAC, we use the word parked car and running car. Parked car are, parked application is basically tools that look at your code and your build images. This is before your app actually starts running. And then the running car is tools that look at your running application when your app is actually running. The limitations with purely doing parked car tools is that you don't have any visibility into how your app is behaving at runtime. You're purely saying that because these are all the things that are happening in my code, or these are all the things that are checked into my, that are in my, these are all the vulnerable components that are in my build images, my app is susceptible to the following 200 issues. But that's a pain because it's 200 issues. Like your developers then have to go through all of these 200 and say, which ones am I going to fix first? If you look at the running car in combination with the parked car, you can actually say, you know what, out of these 200 issues, I only noticed that 50 of them were actually used by my application at runtime. These functions, these class paths were actually called. Therefore, let me go address those issues first. So it's actually a great way, by complementing runtime behavior with parked car findings, you can arrive at a reduced list of insights that you can actually, your dev team actually needs to attend to. The second thing with purely looking at parked car is you have no visibility into your third-party software that your developers are bringing in, other than publicly documented CVE, short for common vulnerabilities and exposures. So if your developer is bringing in some third party, and that third party touches /proc or makes an outbound connection to certain geography that you don't want, then that's not classified as a CVE. It's not a publicly available common vulnerabilities and exposures. So there's no CVE numbers attached to it. So it will go undetected. The only way to detect it is if you're actually observing your application at runtime and say, you know what, your developer checked in this thing, and we noticed that that third party that was brought in wrote a piece of file to /proc, or it loaded a library from /tmp, or it made an outbound connection to Madagascar. These are things that your AppSec team may not want your application to be doing. And if you had observability, you would flag all of those things right away. So observing your application at runtime is extremely important. But if you look at the existing set of tooling that is available for runtime observation, we have IAST, 10 years old, DAST, 15 years old. And these tools are not designed for DevOps because the concept of DevOps did not exist when those tools were invented. Kubernetes did not exist. Cloud native applications did not exist. And these tools are therefore limited in scope. In terms of the attack vectors that they can find, they're primarily like web-related, OWASP top 10 web-related kind of issues that they find. And these tools do not talk to each other. So the fact that you found something brilliant in IAST is nothing to do with your software composition analysis tool. Therefore, you cannot take advantage of what you observed in runtime with your static. Enter continuous observability. That's essentially why we believe that the category of observability for application security is extremely important. It is the next generation tech. And it essentially allows you to observe your app in a shift left world from test and leave it on all the way through prod. So what essentially you could do is you could run your SAST, scan your code, scan your build images using software composition analysis. And then the moment you start running your application, either using manual testing or automated testing as part of your CI pipeline, flip the switch on, use observability. Your app is being observed, every thread, every process, and if you are containerized, every container is being observed at runtime. Both third-party components as well as your custom application components are being observed, and you can take all of this information and use that to arrive at a bunch of meaningful insights, completing your DevSecOps mission. So just like how over the last few years, we've created certain fundamental building blocks for DevOps, CI, for build fast, CD for deploy fast, continuous testing, detect functionality bugs fast. We as an industry need to be continuously observing your application, and therefore there's a need for continuous observability, which basically means detect security, compliance, and performance risks fast in your application as part of the CI pipeline. And for the purpose of this discussion, and for what my company DFactor does, we're focusing on detecting security and compliance issues as part of your CI pipeline. Cool. Let me pause there for a second. Dan, is there any questions or anything you'd like to talk about specifically? Are we going the right track?
Yeah, I think it's important. I like the fact that you covered the options that are currently out there, because not everybody's familiar with exactly what they are and what they try to do. And the idea of moving that all into, I didn't know like some of those things were that old. So that's pretty interesting to know that this predates the way that we're building applications now. I am struggling with this, like I think all people are, to properly secure applications. And if tooling's one thing, but observability is the other side of that. You can't do it without both of them. Is that more or less kind of the idea? Even with the best like preemptive scanning and pen testing and all that stuff, you still have to have a tremendous amount of observability.
Yes, absolutely. I think that's a fundamentally important piece of your, if you were to do justice to your DevSecOps initiatives, you need that. In fact, at the end of the day, everything is a budget question, right? So the way we kind of guide our customers and as we help them in the maturity cycle of their DevSecOps story is that if you've got the budget to buy only one platform, because that's the money that you've been given, then buy a platform that allows you to stay ahead of the risks that make sense for your application. So in a lot of the case, that comes down to mimicking what your application is going to be doing in production, which means get runtime observability first, right? But it so happens that we as an industry have evolved in the opposite direction. We started with code scanners and then dependency scanners, and now we're doing observability. Now, observability is the new thing, right? However, if you have budget to buy one thing, the recommendation is to do that, because that's the closest, in terms of behavior of your application production. Not because I'm building it at DFactor, but that's the right thing to do, right? If you do have unlimited budget, if you have the budget to buy one of everything, then buy an observability platform for runtime, buy a code scanner for static, and buy a dependency scanner as well. Then you've covered kind of all the three aspects of what's necessary to secure your CI pipeline. And in addition, if you have more budget on top of that, I'm sorry, Dan, is there a question?
Yeah, there's a question in the chat. So
yeah, if you have more budget on top of that, then you could add pen testers to it, which could be like a point in time, once in 6 months kind of initiative.
Right. Can you see that question in the chat?
Let me check 1 sec. Will this observability not be heavier than the app they monitor? That really depends on the observability platform. There's a bunch of approaches to observability. Some tools monitor use eBPF. Some tools observe every process that is running in your system. Some tools only monitor the process being observed. So depending on the solution that you pick, if you care about security, then I would recommend picking an observability platform that does application security, that is tailor-made for application security. The performance overhead of that has got to be in low single digits. If not, it's consuming too much overhead. I think you want to make sure that you benchmark it, or you ask the vendor for a benchmark. If your need for observability is for logs, metrics, tracing, performance-related observability, then pick an APM tool, like something like a Datadog or AppDynamics or things like that. If it's a security observability, then you have tools like DFactor or Contrast Security or Sysdig, tools like that. So there's one for everything.
Can you talk a little bit about the compliance listed there? Like can you just get a little bit deeper what you're looking for there. I'd appreciate it. I see the observability through the data center and all the tools coming out with like Thousand Eyes, AppD integration, NetApp Cloud Insights, Intersight. It seems to be the thing of the day that's really different from alerting. But I do a lot with data compliance too, and I don't do a lot with application development, but I just was kind of curious from a compliance standpoint what you're looking for.
Yeah, let me dig into that a little bit. But I think before we get to it, maybe a slide around how to group these observability tools into buckets. That way you know when to use what tool might probably be helpful. So I have a little slide on that. So maybe I'll share that first, and then we'll jump into some of the compliance aspects. Does that sound fair, Jeff?
Oh, that's great. Thank you.
Okay, perfect. So when you think of observability for AppSec, think about it, when you think about actually take a step back. When you think about what is the right thing to do for your overall DevSecOps practice, think about it in two parts, static and runtime. If you have budget to buy one thing, get a runtime platform, because that helps you get your application, get a handle on your application behavior and security risks involved as close to what it would behave in production as possible. If you have budget to buy more than one thing, then you can get a continuous observability platform and then either get a SAST or SCA or container image scanning or both. SCA/container image scanning is usually offered by the same tool. So you can pick like Black Duck or Sneak or White Source for one of these. You can pick Coverity, Barcode or SonarQube if you are light on budget, for SAST. And then for continuous observability on the runtime side, you can pick Deepfactor or Sysdig, one of those tools. If you have that baked in today, then here's the state of the, if you do not have runtime observability today, then here's the state of the art, the state of affairs, which is on the code side, you have continuous feedback coming in from SAST and software composition tools as your developers are checking in stuff that's being scanned and you get visibility, great. But what we're missing is that whole runtime effort. And we talked about not having that visibility during test, during staging, or during prod, because you're not watching it run, watching the app run. And therefore, we talked about AppSec teams finding these issues late, causing delayed releases, engineering team context switching, and all of that. God forbid there's a breach, then breaches cost a lot more. And if you don't have a breach, you're lucky, but it's still 60x more expensive to fix things in prod than it is to fix it in pre-prod or test. So it's good to have that visibility ahead of time, right? Let me jump to answer your question, Jeff. Let me skip a couple of slides. I'll jump to this slide. I think that'll convey. And then we'll jump back to the other one. Cool. So this slide actually talks about the observability tools necessary for various personas, right? So if you think about your overall CI pipeline from a security perspective, there are two personas, broadly speaking, that care about security. One is folks that are setting up the infrastructure and managing it, the ops folks. These would be, your SRE team or SecOps team or just ops team, depending on what you call it in your enterprise. And the goal for these guys is to make sure that you have configured your production environment securely so that when your app is running in prod, all the perimeter as well as other controls are tight enough. Your Kubernetes related security issues are identified properly, other configuration issues are identified properly, all the hosts are scanned for vulnerabilities, so on and so forth. So for that, you use all the tools, the logos that I put in there. These tools are great. They're operator-centric tools, and their primary goal is to find out what things are configured wrong with your infrastructure, so that an infrastructure includes the things that are installed in the host, sometimes on the network, and configuration of your Kubernetes clusters, so on and so forth. All of that extremely important problems to solve for the ops person. And these tools are trying to shift left a little bit these days because the ops folks are trying to get this kind of visibility ahead of time so that they can make sure that they can secure the production environment and lock it down properly. Fantastic. But honestly, the developer doesn't care whether your Kubernetes is configured properly or whether something in your production environment has the right version of your Java that has all the patches in place. Your devs don't care. What does your dev care about? The dev team, including QA, cares about what is there in your application. Is it secure? Is the code that I've written coupled with the third-party code that I brought in, is that secure? Is that behaving securely? The QA person cares about, is the code that my dev team written coupled with the third-party applications, when it's running properly, is it securely running properly? For that, you need a different set of tooling. And that's where there are two types of things that you need to care about. One is the tools that care about your part application, which care about static code scannings and scanning and dependency scanners, things like that. All of the logos that I have in there are great. And on the right side, the tools that look at your running application, and that's where continuous observability platform is extremely important. So I hope this slide kind of gives you a lay of the land as to when to use the right observability tool. So you have observability at the app layer, which is required and important for the dev teams. You have observability tools at the infrastructure layer that is important for your ops team typically. Does that hopefully set the context for you, especially in the context of the Thousand Eyes question that you brought up, Jeff?
Yeah, I think it does.
Okay, perfect. Now let's jump into some of the benefits of observability, and then I'll touch upon the compliance question that you had as well.
Hey, Kieran, have you run into any situations of what amounts to moral hazard? Like if you actually have all of these pieces in place, there would be that tendency for the developers to maybe shirk their duty and assume one of the other four security aspects is going to take up for it. That idea that everybody thinks that somebody else is handling it, so no one does. Have you seen that actually manifest? I've actually seen people calling out that situation in some of their teams.
Yeah, no, that's a great point, Dan. I think what we see here is, oh, it's okay. I can build an app in a buggy way. My ops guys, when they deploy the app in production, are going to take care of it. That's the usual handout because the developers are easy developer, and rightly so, because they have features to build, and security is usually the last thing in their mind. But the problem these days is the attacks are getting so much more sophisticated than they've ever been. So your ops person cannot just cannot secure your application if your dev has written a buggy application. For example, if your ops person has put the parameter properly and they've blocked a bunch of ports except 443, all the attacker needs is 443 if your developer is using a buggy piece of software, or that is still listening on 443, but it ends up getting opening up remote code execution possibilities in your application, or shell code attacks or things like that. All the attacker needs is for your application to do write and execute at the same time for a certain piece of memory so that they can get it, right? So those types of things are will enable you to get in, even though 443 is the only thing that is open. So it is important for both layers to be secure. You cannot just secure one layer and expect the application to magically not be breached.
Absolutely.
Cool. So back to observability, and then I'll get back to compliance, Jeff. Maybe in a slide or two. So what exactly does what types of problems does observability solve for application security? We've grouped them into 4 pillars. The first one is observability gives you unparalleled runtime insights that you're clearly missing in your DevSecOps pipeline today. By simply, if all you're doing is scanning your code or scanning your build images, you're not getting those runtime insights. And if you're doing an occasional DAST scan, you're probably getting some of the OWASP top 10 insights around web-related issues, but you're not catching bad system call behaviors, bad behaviors around applications, reaching out to random places, or writing to random locations and files and things like that. Those are all not going to be caught. So comprehensive runtime insights are extremely important. The second pillar is visibility into your software supply chain. That is a hot topic these days with SolarWinds attack, Kaseya, and some of these things that have happened. And now it's an official mandate by Joe Biden's administration that if you're using a piece of software, especially that needs to adhere to certain compliance standards, you need to make sure that you have a tool that gives you software supply chain clarity, which is software bill of materials. So how do you get software bill of materials? Today's bill of materials is not just show me the list of dependencies that are sitting in my jar file. That's static bill of materials. That's just one part of it. It's not complete. Today's apps are a lot more complex. So the bill of materials should really be, show me the list of dependencies in my jar file. Show me which functions and class paths in that dependencies have actually been called. Show me the libraries in my container images that were actually loaded by my application. Show me the list of ports that my app is listening on. Show me the process names that my app has, so on and so forth. So your software bill of materials has to be both static and runtime. And there's no better way to get that list of insights than something that is watching every thread, every process of your application while it's running. So observability is the right technology set choice to get to a comprehensive visibility state around your software supply chain and get that comprehensive bill of materials. That's pillar number 2. Pillar number 3 for observability is a prioritized list of vulnerabilities around, that can help you reduce the alert noise that otherwise teams can get inundated with around software composition analysis. So if you have the example that I gave you before, is if you have a Black Duck or a Sneak, White Source, they're fantastic tools. They give you a list of several hundred things, that vulnerable components that are checked into your application. Now, observability results will tell you which of those functions, vulnerable libraries, the functions down to the function level or class path level have actually been called. So by correlating the two, you can say, hey, I'm going to take my Black Duck results and I'm going to combine it with my observability platform results. And then I'm going to show, okay, these are the 50 things that I need to attend to, as opposed to these are the 200 vulnerable things that are wrong. So it's a great way to kind of maximize the investments that you've already made in software composition analysis tools, therefore, and still keep your developers happy with lesser number of meaningful alerts. Number 4 is enriched dynamic scan alerts. So DAST is still an important aspect of getting visibility into your application's runtime behavior. And there's many DAST scanning tools. The beautiful thing about combining observability with DAST is that observability will watch inside the application process while DAST is poking at it from the outside. So you can actually feed the results of the observability observations back into DAST to make sure that DAST is scanning all the interfaces that are exposed by your application, maybe passing a Swagger document so that it can scan everything. And also, if something changes between release X and release Y, then you can actually, observability can detect that and then make your DAST only scan the deltas, so your DAST scan times can be faster, so on and so forth. So there's a lot of value in marrying the two technologies together. And if you have an observability platform that actually comes in with a built-in DAST, that's even better. So these are the 4 pillars of visibility that you can get with observability. And if you were to double click on them,
Kieran, before you move on, can you say that again? You lost me, and that sounded really good on the DAST part.
I see. So you can think of, we all know what DAST is, right? Dynamic Application Security Testing. It allows you to scan the application from the outside. And there's a couple of different options that you typically have with DAST tools. One is it can crawl through the web interfaces that your application is exposing and do a web scan of your app, therefore detecting some of the OWASP top 10 type issues that may exist in your application based on the request response, the HTTP response that your application is sending back to the DAST tool. The other option for DAST is it can scan the APIs that are exposed by your application if you pass in a Swagger document or any open API document. DAST tool by itself is useful, but DAST as a concept was designed much before CI existed. Therefore, DAST tools typically take a long time to scan things. Sometimes DAST tools miss things as well because they cannot see what's happening inside your application. Observability, on the other hand, is looking inside the application, and there's no way for an observability tool that is watching inside your process to go scan your process from the outside. But what we did is we combined a DAST product, OWASP Zap, which is a popular DAST tool, along with the observability product in a single pane of glass. So what that results is the observability engine that is watching what's happening inside the process can detect, for example, changes like, hey, a new web service was created in this application, which didn't exist in the last release. So last Monday's release did not have it. This Wednesday's release has it. Therefore, I'm going to pass this new web service API endpoint to the DAST tool so that the DAST tool can actually scan just that newly introduced endpoint. That way, you can have the DAST scan times reduced at the same time, which makes it easy for you to bake into the CI pipeline. At the same time, if there's any new web interfaces, etc., got introduced, web services, for example, get introduced inside your application, you can actually make your DAST tool scan those things. So basically, the point that I'm trying to make is observability by itself is great for pillars 1 and 2 in this diagram, but observability coupled with other tools like software composition tools or DAST tools is even more fantastic because it can help you maximize the investments that you've already made in those tools. Does that answer your question, Dan?
Yeah, it does. That's a really neat idea. I like that.
Awesome. So if I were to double click on each of those 4 pillars, on the runtime insights side, there's plenty of modules of insights that an observability platform should cover. Around system call, risks around behavior violations, so on and so forth. For visibility into your software supply chain, comprehensive bill of materials is important, not just static bill of materials, but static and runtime bill of materials. For making the most of your software composition analysis investments, an observability platform that can feed those insights into your Black Duck, or better yet, comes baked in with some of the SCA features. And DAST, same thing, a platform that comes in built in with a default DAST, but if you can augment an existing DAST, fantastic. So these are all the types of things that observability can do for you, and therefore you don't need to buy 10 different tools. Buy this one thing first, and you get a pretty good head start on making the most of your CI pipeline. Now let me answer the compliance question. The goal of compliance question, with observability, again, Jeff, is to understand. It's one thing to identify, these are the 50 alerts that my observability tool has raised in my application so that my devs need to go fix it to create a secure application. Sometimes it's important to prioritize these alerts based on whether any compliance is being broken, because a lot of the times people just want to check a compliance box because that's what the business driver is at that moment, instead of actually, while everybody wants to ship the most secure application possible, many times shipping a compliant application is more immediate, and it trumps the need to ship the most secure application. So you may not be able to fix all the 50 things that are alerts in your application, but you may want to fix the 20 things that break compliance. So one of the things that good observability tools can do here is comparing these findings and insights that you have and mapping it into frameworks. An example framework could be Secure Controls Framework, for example, or some of the NIST standards, et cetera, that basically gives you a tag and say, you know what, if there's this alert results in this vulnerability, and this is the exposure. And oh, by the way, look at this little tag on this alert, that says PCI 3.1 section 4.2. Because if you don't fix this alert, you're not going to pass PCI section 3.1, PCI 3.1 section 4.2, something like that. I think by highlighting and putting tags on some of these security findings and mapping them to compliance frameworks is extremely important, because observability inside your application layer by itself can never give you that, can never make you PCI compliant, because PCI compliance or any compliance standard for that matter is not always looking at the application only. It's looking at some of the processes and other things that go around the application. But I think if out of the 282 checklist items for a certain compliance framework, for example, if you had 70 of those things come from, belong to what's happening inside the app, if you can check them off by having a good observability tool, then that's fantastic. When your auditor comes along, you can actually simply pass the results of this to the auditor and say, you know what, out of these 282, I will help you fill out some of the other things that are process related, but for inside the app, these 90 alerts, these 90 insights, here's the value. Here's the output that will feed into your compliance spreadsheet. Does that kind of answer your question, Jeff? We'll take silence as a yes.
Yes. Sorry, can you hear me?
Yeah, now I can.
Okay, sorry about that. Yeah, I was on double mute. Yeah, I think that's invaluable for me because I never heard anybody describe software development and compliance like that. I usually deal with, compliance more on just the data side, not on the application side. So thank you for that.
You're welcome. Basically, at the end of the day, if you take a step back and simplify this whole concept of observability at the application layer drastically, what's really happening is this tool, or in a good observability tool, will give you binoculars inside your application layer. Now, what can you do with those binoculars or magnifying lens is you can use that to find security flaws. You can use that to map those security flaws to compliance. You can also use that to find compliance related or performance related issues. There are tools that specialize in each one of these things. And I think picking the right set of tools for the right job makes a lot of sense.
And you can also use that to make your developers better.
Absolutely.
One of the things I keep running into is developers that are reluctant to sign up for being like the security person, because it's a hard job.
Yeah.
And so you could use this as feedback into their code review process to show, yeah, you can do this, this, and this, and be better in the future.
Yeah, absolutely. I still think that there is value in having either the engineering leadership or the AppSec, dedicated AppSec person to be the point of contact for the setup of the tool and the governance of which policies need to be flagged and which policies trigger alerts and so on and so forth. But once the governance is established, the day-to-day use of this tool and the insights need to be consumed by the individual developers. And the smoother and the more seamless you can bake it by seamlessly baking them to your CI pipelines, GitLab, GitHub, whatever pipeline you use, the better the end result would be. And the lesser the number of alerts that you raise and the more evidence that you can provide in each of these alerts, the better the tool.
Yeah, I like that. Never even thought of the developers being a consumer of something like this, but you're right, they should be.
Right. Cool. So now if you have it in place, then you not only get feedback during the code stage, but during your test, your staging, and even in your production, if you enable it, you get continuous feedback from inside the application layer around security. And what that means is you can ship fast and ship secure. You'll have much lesser breaches than before. Your mean time to resolve issues is going to be much better because you no longer wait till the end of the release for the AppSec testing to happen. If you check in something that is suspicious, you will know that that very night when your application is running as part of your tests suite. And all of this results in significant time savings to the engineering team and significant financial savings for the organization. And of course, all of this resulting in better security posture and happy ops teams overall. Because if your app is secure, then the ops teams have a lot more peace of mind when they run the application in production widely. So to summarize, here's what we generally say inside our company. Good engineering teams move fast. Great engineering teams move fast with confidence. And observability is one of those tools that can give you that confidence. So now you know how to start left, not shift left, but start left and secure right at the source and create a culture of creating secure applications to begin with, as opposed to throwing an application over the wall and letting the ops people figure out securing the perimeter aspect of it. Any questions?
So are you in the business of selling tooling at Deep Factor, or are you in the business of selling consultancy on security, app security?
We are one of the pioneers in creating an AppSec observability platform. So, if you have questions on that, if you want a demo of our platform, you're more than welcome to contact demo@deepfactor.io or just go to our website. There's plenty of interesting data and content there. We're a team of security experts that, we're actually a team of 3 sets of expertise: cloud native expertise, security expertise, and observability expertise. We've created a cutting edge AppSec observability platform that essentially answers and solves these types of problems. We do couple it with some professional services occasionally so that we're not like take this tool and run with it. We actually guide you through what is the right way to set up your DevSecOps and help you wherever we can with the whole process.
Okay, outstanding. Any questions from anybody on the call? Okay. Well, Kieran, that was fantastic. I mean, you hit me right between the eyes with that. I am neck deep in all of those issues and concerns. And I actually read that Biden executive order. So yeah, if that stuff actually starts becoming law, all those people that are dealing with government entities, they've got some heavy lifting to do. I
Yeah.
hadn't considered that the software bill of materials is much more of a dynamic thing than like an artifact of your build process. That's another important point.
Right. Yeah. It's a more complete way of thinking about it. Right.
Absolutely.
Awesome. Hey, any questions or anything at all that you have outside of this meeting? So please feel free to reach out to me.
Igor's asking for the slide deck. Would we have the ability to share the slide deck?
Yeah, Amy, would you be able to share the slide deck?
Yes, excuse me. I'll send a PDF over to Dan.
And I can upload it and put a link on the DevOps meetup page.
Awesome.
That's really cool stuff. Really cool stuff. One of the things about app security, Kieran, that occurs to me is I'm a big Tolkien fan. And it reminds me of the elves, because security, the job's never done, and you're going to lose eventually. It's way too easy to miss that one thing, and you're compromised. It's like you're
Yeah.
constantly fighting a losing battle. And of course, no one's going to appreciate it. You're right. If you come forward and you say, look, this is a problem, this is a problem, this is a problem, you are suddenly the bottleneck to production. So we're always on the wrong end of the argument, seems like.
Yeah. No, it's true. And I think the way to become a hero is by setting the right framework in such a way that, a lot of the volume of insights that are triggered and the queue that you add to your dev teams is not too much. But whenever you add something, it's meaningful with the right amount of evidence information in there, so that they're like, you know what? Yeah, this is a security hole. I'm glad you brought this up. As opposed to, oh, don't give me another list of 200. Yeah.
Absolutely. Okay. Well, if there's no other questions, then I guess we are done for the day.
Well, thank you for the opportunity, Dan. Really
Again, the contact information, demo@deepfactor.io.
Yeah.
Okay. Fantastic. Great. All right, all. Well, like I had mentioned, live and in person, September 21st is the plan. September 21st and 22nd, Houston DevOps Days. Be there. It's going to be fantastic. And keep an eye on the meetup page. We're going to come back with another couple great ones in August. So have a good day, everybody.
Awesome. See you guys. Bye.
Bye.